right, so we are finishing the note sheet over 1.1 today. I believe we got to this page, we were talking through this, yes? Or did we get through the end of this slide? Okay, so we did the first two here. All right, guys, let's find a seat. We will have official assigned seating on Monday. Yeah. It will be random. I use a number generator to randomly assign seats. Now, the seat assignments, I will put them together. I will tell you we will sit there, and it's for the first 9 weeks, I do assign seating for two reasons. One, for the calculator number. The calculator number that you're assigned is going to be based off the desk number. That's why all the desks are numbered. I find it easier to remember a desk number or desk location than it is to remember just a straight number for your calculator. And two, it does help me memorize names faster. It is always an uphill battle for me, at least remembering names. Now, we will do that on Monday. I will get you those there, and we'll go from there. Normally at about the 9-week mark, after the first 9 weeks, I will have your names for sure memorized by then, and also you'll probably have your calculator number down of which one is yours, and I will open the seating back up. You can sit where you want, as long as it does not become too disruptive. And that's how I do it every year. Okay? Now, where we stopped off yesterday was talking about set builder notation. Set builder notation is used to help us be able to describe a set or group of terms, numbers, that is not easily writable, as in we can write them all out or create a pattern. Like we saw yesterday with the set of all real numbers, I believe it was greater than or equal to 1 or greater than 0. It's just not doable. So this gives us a way to do this. We talked about the first one, brace x bar, the set of all real numbers, such that, and then we have our description, x is less than a. And as we looked at the graph of this yesterday, we got something like this here. The second one, the set of all real numbers such that x is not equal to 3. Well, we ended up just shading the entire number line except for 3. It's everything but 3. Now, the third one we didn't get to, the set of all real numbers such that -4 is less than x is less than or equal to 6. Really, the first part, like all of these here, we have all numbers. We're just talking about the whole number line. We're not excluding anything. It is that entire number line. But we really only want the points, or the numbers, between -4 and 6. So especially if we're talking about graphing this, it's really saying we're using the whole number line. Graph that inequality. That's really all it's saying. So we know we're going to want -4 and 6 as our endpoints if we were to graph this. And we put 2 circles at both of those points. Now, the next two things we need to do, one, we need to figure out where we need to shade, and two, we need to figure out if one, both, or neither of those circles are filled in. For the circles, -4, is it included? Is x equal to it? No, because it's just -4 is less than x. Is 6 included? Is it equal to 6? Yes. So we would fill it in. And because x is in the middle, we shade in the middle. Questions on this here? Now, one thing you can actually do, especially with any of these inequalities, we can actually refer back to the charts. They're like what charts? If you remember yesterday or the day before, yesterday when we talked about bounded intervals, might be nice if that's not filled up. We had, no, don't delete that. Go away. -4 is less than x is less than or equal to 6. Negative 4 is less than x is the inequality we're trying to graph and use, yes? What took the place of A in this setup? Negative 4. What took the place of B? 6. A is now negative 4, B is 6, yes? Which one of those 4 do our signs match up to? The fourth one, yes? So I can go back to this here. A is negative 4, B is 6, yes? So here we would say A is negative 4 and B is 6. Because it matches up with that one at the bottom, we can just replace A and B. I have the interval notation. If I wanted to graph it, we just say A is now negative 4, B is now 6. I can mirror that on the graph. Normally we don't come back to this or utilize it much. We just say this is the definition and we move on. But again, as I said the other day, these 4 show us all bounded intervals. So if we compare and make it 1-to-1, replace A and B with what they correspond to, it will give us all 3. Kind of nice. Any questions on that third one? Now the fourth one, we add a new symbol. We add this weird looking E, yes? What this is saying, X is an element of. X is a part of a group. And up to this point, we've been saying that X is a part of the real numbers. X is a real number for all real numbers. Now, I could put this here. You don't have to write this because it's redundant. X is an element of the real numbers. If we're saying that, we're not going to use that at all. We'll just use X, brace X bar, because X is a real number for all real numbers. This is useful when we're not talking about the real numbers. Z, our Z with an extra line, is our integers. So we're saying X is an element of the integers. We're only looking at the integers. So if we want to change the set or type of numbers that we're using, we can use this notation. X is an element of the integers, such that X is greater than or equal to negative 9. Luckily, we were not going to have to graph one like this here, because integers are our positive, negative counting numbers. Because if we're to graph this, well, we would start with negative 9, and it would be included, but we'd also have all of our other points, because we're not going to have the whole number line, so we can't just fill it all in. We'd have to just make a point at each and every integer. I did 5 of them. I'm already tired of trying to graph all that. It's just not doable. I mean, there's no reason to do that. So we're not going to be asked, I'm not going to ask you to graph something like that there. The same thing is true with the last one. Brace X bar, the set of all real numbers such that X is even. Graphing all the even numbers, that's just making a whole lot of points on a line. Not a whole lot of reason to do it. But I'm showing you especially these last two so we see there are different ways that we can actually do these and write these. Okay? These are not the set ways either. Especially for this one here. Because the book would have us do brace X bar, and there's nothing wrong with this. I don't disagree with this. We want to say X is an element of the integers. X is an integer, and X is greater than or equal to. That is saying the exact same thing. Those are the exact same statements. I don't like that one as much because that's a lot more writing. We're having to actually write the whole thing out. And yes, I mean, we could combine the symbols I just showed you. For all real numbers, X, such that X is an element of the integers, and X is greater than or equal to negative 9. But almost, if we're going to do that second way, we might as well just stuck with the first one to begin with. We're just having to write more for the sake of writing more. And like I said, mathematicians are lazy. If we don't have to write a whole bunch, we're not going to write a whole lot. Questions on how we wrote these? If we did a proof, if we were doing proofs, you're not going to have to do proofs. They actually have a different way they write these entirely, especially as a proof statement. Similar notation, similar pieces. Not so much talking about sets. You don't need to write this one at all. They're not real numbers. We want integers. Like I said, lazy. We just condensed the whole thing. That upside down A is all for all x in the integers. X is greater than or equal to -9. Like I said, mathematics has their own way of writing things simpler. Unless you go into a pure math course or a pure math degree, you're never going to see that ever again. They use that in proof statements for all. There's an exists, which is a backwards capital E. Don't know why they do it that way, but that's the way it's been done. Questions on set builder? Okay. Now the first thing we're going to do is actually not write in set builder notation. We're going to graph from set builder notation. So they want us to graph this here. For all real numbers x, for all real numbers x, such that 2 is less than x is less than or equal to 5. That first part for us, especially with graphing, is saying we're using the whole number line. Any value, any real number is going to be included, such that x is going to be between these points. So the group of numbers we're using is all the real numbers, the whole number line. Could be included, but it's not. We only want from here to here. We only want this. As long as it satisfies that, it works for this here. Is this bounded or unbounded? Bounded. How many endpoints do we have? 2. They gave us 2 numbers and x is between it, yes? So it is considered bounded. And our 2 bounds are 2 and 5. 2 and 5. Now we need to figure out which one's included and which one's not, or if both are included or neither is included. 5's included. We have that equal to. We have that line under the inequality sign. So it's saying it's equal to it. It's saying it's included, so we would fill it in. 2 is just less than. It does not have that equal sign with it, so we don't include it. And since x is in the middle, we shade in the middle. That's it. Any questions on this here? All right. Let's look at B. The set of all real numbers such that x is a part of the real number, such that x is less than or equal to 0, or x is greater than 4. Now, this is what we call a compound inequality, which for us doesn't mean a whole lot, because the most compound inequalities we'll look at, especially in this here, I said we weren't going to look at many, but ORs are nice. We just put everything on the graph. It's going to be either one. And we can look at them independently. So the first one we're graphing is this here. X is less than or equal to 0. Now it tells us one endpoint is at 0, yes? So we can go to 0 and make a circle. That's one of our points. Now we need to figure out, is it included? Is it equal to it? We have that equal to sign. So it is included, so we would fill it in. So we have that. Now we just need to figure out if we're shading to the left or to the right. That's where we sometimes get stuck, yes? Shade to the right. So what's a number to the right of 0? 4. So one thing we can do, especially if we're not sure, is pick a point to the left or to the right. So 4 is to the right, yes? So we'll plug it in for x. Is 4 less than or equal to 0? Well, no, because it always points towards the bigger number, yes? 0 is not bigger than 4, so can we say this is a true statement? No, this is not true. If it is a true statement, we shade that direction. If it's a false statement, we're going to shade the other way. We're not going to include it in the shaded region. So let's pick a number going the other direction. Well, let's say negative 4. Is negative 4 less than or equal to 0? Yeah. So that's included in the shaded region, which means we have to shade this way here. Now the question is, could we have done that on the previous one? And yes. If we picked a point between the two, picked a number between our 2 points, and it works, we're going to shade between. If we don't, we're not shading that area. So this gives us a great way to actually check and see where we're shading, what's included and what's not. That kind of makes sense? Now this seems like something that we just kind of do as a helpful trick. It's not something that's actually taught in the books. It's kind of deal. Funny enough, this is called the tester method. And especially when we hit higher degree inequalities or equations, inequality equations, this is the method they say to figure out actually how to graph on a number line. What's included, what's not. We get tester points. We get points in the regions between the points, like on the last one, between those spots, and see which one works, which ones don't. If they don't work, that section gets thrown out. We don't shade it. If it does work, we shade between those points. And that we would try, for the last one, we would try 3. Is 2 less than 3? Less than or equal to 5? Yeah. 3 is bigger than 2, so that's fine. 3 is indeed smaller than 5. So that fits. So we would shade between them. It's one of those things that doesn't feel like it should work that way or is an actual method, but it does. Any questions on the first two? You're right. We should finish number 2, yes? Yeah. Because we also have what? X is greater than 4. So what's our next point? 4. Opened or closed? Open. We don't have that equal sign underneath. Now, do we shade to the left or to the right? To the right. So is 5 bigger than 4? So we shade that direction. And that's it. And part of the reason that we can put both of them on there, as long as the number satisfies one of those two, it works. Because 5 does satisfy this side, so it's good here. It's good for the overall statement. Even though 5 is not less than or equal to 0. As long as one statement's true, it is part of the solution set. Any questions on B before we look at C? Sketch the graph of the set of numbers. So for all real numbers, x, such that x is less than -2 or x is greater than 0. 2 statements, we're going to graph them independently. Now, it doesn't matter which one we graph first. I always graph the one listed first, but it doesn't matter for the order of this. Now, the number they give me for this unbounded set is -2. Would -2 be included in our solution set? No, we don't have that equal sign underneath it, so it's going to stay open. Now we need to figure out, are we going to shade to the left or to the right? We're thinking left, so -3. Is -3 less than -2? Yeah, so we would shade that way. That's it for that half. X is greater than 0. So we do know we have a point at 0. Is it open or closed? Open. Are we shading to the right or to the left? So 2, just to the right of it, is 2 greater than 0? Shade to the right. That's it. Now, some of these do show up on the ACT. I don't know if they'll give them in set builder notation, but they do say graph the following inequality. Yes? The way I would tackle this, especially on the ACT, is based off the answer choices. One of those answers has to work. One of those answers has to be correct. Yes? If they're asking me to graph it, the first thing I look for are the points. Are the 2 points, especially if it's already in this form, x is less than -2 or x is greater than 0, is -2 and 0 located on that graph? Also, are they shaded correctly? Because there's a good chance that at least 1 or 2 of them are shaded improperly. Because if they're both not open, those answer choices are gone. Then I would shade the first one. X is less than -2. We got it shaded. I would check the answer choices, see if it matches or doesn't. Any that don't, gone. There's about a 90% chance you've eliminated 3. I don't need to finish because that last answer choice is the correct answer, and we move on. Unfortunately, we don't get multiple choice here. Please see how that works. Questions so far? Let's look at 2 more. For all real numbers x such that at -6 is less than x is less than or equal to -2. Now, especially on the homework, I gave us a number line here. You're not going to get one when you have to graph these, but the first thing you're going to do is draw a number line. Now, this is bounded, yes? So what are our 2 endpoints? So we do need 2 endpoints, yes? Smaller on the left, bigger on the right. I do not need a 0. I do not need a scale. What's the relevant information? Those 2 points, yes? Even if it was a single unbounded interval, we just need 1 point in whichever direction it's going. Is either one of these included? -2 is included, so we need to fill it in. As long as we see that it is filled in, that's good. You don't have to shade it all the way in unless you want to. Now, because it is bounded, it means we have to shade in the middle. That's about all you have to do with shading. Give me a squiggle line, you're good. I don't know about y'all, sometimes it's hard to see. Shade right on top of that line. It disappears right into it. That's it. Questions on this here? Be ready for the next one. For all real numbers such that x is an element of the real numbers, x is a real number such that x is less than or equal to 0 or x is greater than or equal to 10. I need 2 points. One of them 0, one of them is 10. Since they have that equal sign on both, they're both going to be closed. X is less than or equal to 0. Would we shade to the left or to the right? Left, because it's smaller, yes? Thank you. X is greater than or equal to 10. Would we shade the left or right? The right. Okay. Opposite, yep. Now, or statements, I would say about 90% of the time are going to go in opposite directions. They do not have to. They can go in the same direction, or essentially they'll go in opposite directions. They just go towards each other instead of away from each other. If that ever occurs, you're shading the whole thing. It is going to be the entire number line. It just ends up being all real numbers from negative infinity to infinity. Kind of nice. Questions on these here? Writing the sets of numbers in set builder notation. Now, the nicer ones for set builder notation are the ones that either give me a nice description or are already in inequality form, are already written as an inequality. Intervals we have to rewrite as an inequality. So we look at the first one, the set of all integers greater than 5. So we know we're not talking about the real numbers anymore. We're only talking about integers. And we also have to rewrite this wording greater than 5 as an inequality. And we're going to use x as our variable. We always use x because x has been defined as unknown, the unknown quantity. So x, so then we would use our greater than symbol. 5. X is greater than 5. Questions on how we did this so far? Now that is half of our set builder. That is the description, how we're describing it. So that's part of the set builder that goes after our bar, that's such that. Because set builder notation, brace, our number type, bar, such that, description. We got the description, we can put the bar in. Now we just need to describe the types of numbers. If this had said all real numbers, it doesn't. If it did, all we do is brace x bar, if it was real numbers. But since it's not talking about the real numbers, all we have to do is make one little change. We have x is an element. X is a part of the integers. And our integer symbol is the z. X is an element of the integer such that x is greater than 5. We describe the number set such that this is the description. This is our group of numbers such that it's greater than 5. That's it. Questions on this here? We ready for the second one? They gave it to us in interval form. We need it as inequality, so we need to change it from intervals to inequalities, yes? There's two ways we can do this. One is just knowing how to rewrite these as an inequality. Inequalities do have variables. Since they're unbounded, we're going to have x, one of our inequality symbols, then that number. Either greater than, less than, greater than or equal to, less than or equal to. And as we look at this here, I know the parentheses next to the -1 tells me it's not going to be equal to. So we're looking at just greater than or less than. And for this first one, we're saying it's all the numbers from negative infinity to -1. So we want all the numbers smaller. So it would be less than. X is less than -1. And again, I said there was two ways that we can do this. That is an 8. This is the interval we're trying to rewrite as an inequality, yes? Which of those four does it match up with? The fourth one, yes? What is A? It's become -1, yes? Which means this A is going to become like I said, this chart, these four describe all unbounded intervals. I just had to match it up and see what A was taking the place, or what took the place of A. It tells me X is less than -1. Or, we always keep that. Now we have -1 comma infinity. If I want to use this here, erase that, erase that. Now which one are we using? The second one, yes? Which means its inequality form should be in the form of this here. And it's telling me X is greater than -1. We will. Any questions on how we wrote those? That's kind of nice, isn't it? Now we need our braces. We need the rest of it. Did it tell us what number types we're working with? No and yes. Anytime it just gives us intervals, we're talking about all the real numbers. We're not excluding anything, which is nice, which means the first part is just brace X bar. When we're talking about all the real numbers, it's just brace X bar, the all real numbers, the set of all real numbers such that X is less than -1 or X is greater than -1. Brace. So really the main thing we had to do was just convert it over to inequality form and put it in braces. Questions on this here? Are we ready for the next one? -infinity comma -1 or 1 to infinity. Do we want to keep using the chart? It's up to y'all. If y'all find the chart useful, we can go to that. Because again, it is unbounded. I saw that. Because our first part is this statement here, yes? Which of those four interval notations does this match to? The third one, yes? Which means its inequality form is going to come in the form of X less than or equal to A. But what is A? A is corresponding to -1, which is telling us X is less than or equal to -1. Because -infinity comma -1 is saying all the points, all the numbers that are less than or equal to -1. X is less than or equal to -1. Or 1 comma infinity. So we're starting the other unbounded interval where? 1. A is 1, and we're going bigger. So X should be greater than 1. Since it's a parentheses, it wouldn't be equal to. We'd have this here. Again, it still works with this. 1 comma infinity. It's the second one. A would be 1, so we're X is greater than A, so X is greater than 1. Brace X bar, because it's all real numbers. Finish off the brace. Questions on this here? We ready for number 7? Number 7, I think, is going to be one that y'all will like out of all of them because it's one of the nicest ones. I think it's nicer. The set of all integers except -4. So what we're saying, it could be any number, any integer, but what? -4. So what can x not equal? X cannot equal -4. If we're saying it's not equal to it, it cannot be this. It is not this number. It's anything but this number. We're saying that x cannot be -4. That's all we need for the description. It feels like we need to say, well, x is anything less than -4, and anything bigger than -4, x is greater than -4, or x is less than -4. We could do that. Or we can just say x is not equal to -4. What type of numbers are we talking about? So x is an element of the integers. Brace x element of the integers such that x is not equal to -4. Questions on this here? We ready for the next one? When you look at sets, especially the first two, we need to determine if we're using set builder or not. This one here, the whole number is 50 through 54. Let it be 50, 51, 52, 53, 54, yes? Is that writable? Yeah. I wouldn't use set builder for this. We can just go, cool, 50, 51, 52. Done. If I can write it easily or make a pattern, we're just going to write the pattern or write out those numbers. There's no reason to do the whole set builder. We can't list all the real numbers from 0 to 4. We saw that yesterday. So here, we're going to actually have to write it in set builder. Now, the numbers 0 through 4, zero is less than or equal to x is less than or equal to 4. Probably is going to have just less than. Then we have to put our brace x bar. 0 is less than or equal to x is less than or equal to 4. So we need more information here because it's not able to write it out. That's the only big difference. Questions on this here? All right. We are done with 1-1. So, yeah, we're good with that one. Really, that's writable because we can go -100 or -100, -99, -98, ... 99, 100. We can set a pattern, and then we can put a number after the ... to say it ends here. 5 through 14, so 5 through 14 all. 5 and 6. You can write those nicely, just parentheses, list the numbers out, list the pattern. 7 through 16, graph it. Write it as an interval. So you're using your parentheses, brackets, and our numbers. 17 through 20, you are graphing it. So graphing it on a number line. 21 through 24, 26, and 27, you're writing it in set builder. Now, especially with the set builder, that's new, it's a challenge. If you get stuck, email me, ask me, or Monday, first thing before we start the lesson on Monday, I will take homework questions. So if there's any of those that you want to look at, ask me. Ask me, then I will take homework questions then. Also, if you do not want to raise your hand and ask for problem number 27 at the start of class, just come up to me, hey, can we look at this problem? I'm not going to call you out. I'm not going to single you out. I'm just going to say, hey, we're going to look at this one first before we get started with the notes. Okay? If you have any questions, always ask. Always ask. I like questions. I like answering questions. All right? That is it with 1-1.